Somewhere and put it off the side.
All right, let's, number 2, come on, focus. These were the first ones we looked at on Friday. For these, looking for asymptotes, that we call them hyperbolas if we graph them. All right, we can tell the answers by looking at the problem. So these are the really easy ones. So what is the vertical asymptote?
1.
X equals 1. Good. Remember, it's a equation of a line, so we should write x equals for vertical and y equals for horizontal. And the domain is everything but 1, right? Just whatever makes the denominator 0 is our vertical asymptote. So this was BA. Okay, horizontal asymptote is whatever's out here. Okay, so it's a positive 2. So it's y equals 2. And then our range is y is any number but 2. Okay? So when it's in that form, that function's in that form, it's real easy to do. Don't have to do any factoring or anything. You just look at it and answer it. Okay, yes?
Can you get 1 from the vertical asymptote?
Whatever makes the denominator 0. Okay? On this one, number 3, it says identify zeros, asymptotes, and holes. All right? So this is when we got to factor. All right, let's do this. Move it up some. All right, so when I factor the top, I've got x times x. It's a regular trinomial, no GCF. And it's a -2 and a -1. -2 times -1 is a +2. And -2 plus a -1 is -3. In the bottom, the GCF is x. And then you can write x minus 1. All right, so there it's factored. Now, what do you see in the top and the bottom? An x minus 1. So that tells you what's going to happen. What did we say? That's the last thing we talked about on Friday. When that happens, what does that tell you? There's a hole. Hole at what number? What makes that 0? 1. So the hole's at x equals 1. Okay? You do that first. You take care of the hole first if that happens like this. All right? So what's my 0 now? +2, right? The zeros are what makes the numerator 0. What makes the denominator 0? No. Got rid of the x minus 1. So what's the other variable? Yeah, x. What makes x 0 is 0, right? Which is the y-axis. Thanks. All right, is there a horizontal asymptote? What's the degree of the top? 2. What's the degree of the bottom? When the degrees are the same, is there a horizontal asymptote? Yeah, there is. if the degree of P is equal to the degree of Q, P was the top polynomial, Q was the bottom one, numerator, denominator. So we got a 2 and a 2, right? So they're equal. The horizontal asymptote is the line y equals leading coefficient of P divided by leading coefficient of Q. What were the two leading coefficients? What were they? What's the leading coefficient here? What's this one? So what's 1 divided by 1? 1. Okay. And then graph. So there's a picture of it. Hole at 1. So there's the hole. Okay. Your horizontal asymptote at 1. Vertical asymptote at 0, the y-axis. And your hyperbola, your two pieces. It's a discontinuous graph, right? Because there's a break in them. So that was like everything in that problem that we talked about on Friday. All right, so there's your answers to your homework. So check your answers. Again, if you have to graph, you just graph on your calculator. Any questions up to 13? Then I'll show you the last 3 here in a minute. Yes, Grace. Okay, so you're going to go to your y equals, right? So let's look at number 10. So number 10 was x squared over x minus 1. Okay? So x squared over, and then I told you to put, those in parentheses, that bottom part. If you have more than one thing in the top, you put it in parentheses too. So x minus 1. If you don't, it thinks that you're going to do, it would have thought you're going x squared divided by x, and then minus 1. All right? And then you hit graph. It's got that little, so that's this one here. Okay, our asymptotes, the 0, or what makes the numerator 0, so the x squared part, I got to put a 0 in for x to make it equal to 0, right? 0 squared is 0. So that's why the 0 is at 0. The vertical asymptote, it was x minus 1 in the bottom. So if I put a 1 in for x, I get 0 in the bottom. So that's why it was x equals 1 for the vertical asymptote. When the degree of the top one was bigger than a 2, then the degree of the bottom one, it had a 1, there is no horizontal asymptote. Okay? When the degree of the bottom one's bigger than the degree of the top one, what did we say it was? Y equals 0. Okay? So, degree of the top, here's your horizontal asymptotes. Listen again. Degree of the top one is bigger than the degree of the bottom one. There is no horizontal asymptote. Like that example there, number 10. If the bottom one degree is bigger than the top degree, then it's always y equals 0. It's the x-axis. And then, like the that second warm-up problem, if the degrees are the same, then whatever's in front of the first one, you know, in front of the top, divided by whatever's in front of the bottom, the leading coefficients. That's what it is. And this, the one we did was 1/1, so it was y equals 1. So just do it in your calculator if you have to graph. All right, the last three are right there. 14, 15, and 16, that, what?
Can you come here real quick?
Okay, I get you. Any questions on any of the last three?
My calculator doesn't seem to be graphing this right.
All right, hit zoom, 6, 1. Did it start working?
It creates a weird shape. It's like I don't know.
Oh, it hooked them together. Sometimes it'll hook them together. That's not really supposed to be. Anybody else have that?
I don't
Look
know.
like a heartbeat?
Are you supposed to have like parentheses?
When you put it in, yes. Sometimes you'll see these, like this one here, like number 13, you'll see this one, and then it kind of bumps and does that. Sometimes yours will show that. That's really not supposed to be there. Like you're a doctor and looking at the EKG or whatever they call it when they're looking at their heart, and you see those. Sometimes your calculators will have that little line connected. That's what Coles is doing. Okay? But usually that's where the asymptote is. Okay, remember, an asymptote is a line that the graph approaches, but not supposed to touch, right, Danny?
Nice. Love Danny. He actually has so many. It's incredible.
All right, any other questions? No other questions? We're good with the holes? Dan? All right, well, let's look at 14 then. All right, so the first thing we're supposed to do, so we can figure out zeros and vertical asymptotes and horizontal asymptotes, is factor. Okay, some of you did not do that. Factor. Okay, so I've got x minus 3 times x minus 2 for the top. Negative 3 times a negative 2 is a positive 6. So when I add those two numbers, I get negative 5. And then the bottom is minus 3 and a minus 1. When I multiply negative 3 times negative 1, I get positive 3. And when I add them, I get negative 4. All right, so the first thing that if you have the same factor, top and bottom, like we do here, they cancel. And that tells me there's a hole when a factor from the top cancels with the factor in the bottom, like this. Okay, so there's a hole at x equals 3, whatever makes those into a 0. 3 minus 3 is 0, right? For your zeros, it's what makes the numerator equal to 0. What number goes in for x to make that a 0? Positive 2. So that point, that's where the graph will cross your x-axis. Okay? The vertical asymptote is always what makes, it's x equals, because its vertical line is x equals. And it's whatever makes the denominator 0. So what number makes that 0? 1. Look at the degrees of the beginning. Degrees are the same. That means there is a horizontal asymptote. So we need a y equals. Just do it here, 'cause we're running out of room here. Okay, and then you take the leading coefficient, which was 1 in the top, divided by the leading coefficient, what was 1 in the bottom. So that's 1. All right. So then, to graph it, put, you can put the original in if you want. I'd put the original in. All right. So, excuse me. So I have, and again, put them in parentheses. X squared minus 5x plus 6 divided by, parentheses, x squared minus 4x plus 3. And then hit graph. Okay, so when I draw it then, I'll just do it this way. Okay, so horizontal, let's do it this way. Switch my lines. Horizontal asymptote is y equals 1, so it's like right there. Vertical asymptote is x equals 1, so it's about there. Okay. 0 at 2. Right here, across the x-axis. Whole at 3. So at 3 here, we would have to make a little hole where right above in that area, right above the 3, where that line was. There would be the hole. And that was which one? 14? The better picture of it here. Okay. Does that help?
Can you figure out the difference again between the vertical and the horizontal asymptote? Yeah.
Vertical is always what makes the denominator 0. Okay? For the horizontal, there's 3 things we could, 3 possibilities. So these are all the possibilities. All right? If the degree of P is bigger, the top is bigger than the bottom, there isn't one. If the degree of the top is less than the degree of the bottom one, again, P is the top, Q is the bottom, then it's y equals 0, which is the x-axis. Okay? And then if they're the same, like we've had a couple today that were the same, whatever's the leading coefficient at the top divided by the leading coefficient at the bottom. The 2 that we did were both 1s. It was just 1 divided by 1. And it's always y equals for horizontal asymptote. Vertical asymptote is x equals. Again, for the zeros, it's whatever makes the top 0. Okay? Any other questions?
Yes, sir.
Okay, so I just want you to practice these some more for tonight. Nothing new, just practice some more. All right? So, somewhere here, I have I guess I didn't put it down here, but I will write it down for you. Same page. Was it 650? No, that's my other class. 597, right? I think it's just 20 to 30 even. Yeah. 20 to 30 even. So it's not bad. You probably could get done before you leave here.